Okay, so let's say we have a Venn diagram. And here's what we know. This is a little different than what we were doing previously. Let's say instead of having each element listed out, we're just going to put how many elements are in each part. So, the universal set is the whole rectangle, but let's say on the outside here I've got 7 elements. I don't care really what they are. There's just 7 of them out there. In this part, we've got 6. The middle, we've got 8 elements, and then in the moon-shaped B part, we've got 2 elements. Okay, so those aren't elements themselves. That's just telling me how many is in each part. Instead of having to write out 7 elements, we're just going to say, well, there's 7 elements out there. Okay, so it's a little different than what we were just talking about previously. Okay, you with me there? All right, so here's what I want you to tell me. Number 1. We haven't used this this notation here yet today, but what is that value? Yeah, what does it mean?
Union.
N of A, in parentheses A. Remember, that's the cardinal number. That's our notation for cardinal number. Yeah. And what's the cardinal number? Number of elements? Just a little quick review. So this is just asking, what's the number of elements in A?
6.
All right, now remember, the Venn diagram, the whole circle is A. This is A, right? A is that whole circle.
B6
6 and 8. 14. Yeah, so don't get to thinking, A is just this set. A is everything in A. So it includes the intersection and that. Okay? All right. Number 2. B, and we can do the same thing with B and various other things, but all right. What's then this? What would be the number in A and B? The number in A and B. Okay. Going back to our definition of sets, set operations. If you go back and look at your notes, I gave the definition, if you will, in a couple of ways. I kind of did it the formal way, and then I gave you, well, this is what it means. Well, if you go back and look, the word "and" is in which of those set operations? Anybody write it down? What was "and" in the set operations? Which one of those was the set operation that had "and" in it?
Intersection.
Intersection, yeah. And, if the word is "and" in something like this, "and" means intersection. The "and" means intersection. So the number in A and B, that's asking how many are in the intersection. So what would the answer be?
8.
It'd be the 8, yeah. The intersections are right in the middle there. Okay? So if the word is "and," it's the intersection. All right? What would then, is that okay? Are you with us? Number 3, the number in A or B. Well, you go back and look at the definition, the "or" was used in which set operation? That was union. Yeah. Or, the word "or" means union. "And" means intersection, "or" means union. So there's a few more in this set. It's not just, so or means the union. So what I'm looking for is, well, which ones are in A union B? That's the ones I want to put together here. So which ones are in the, so that goes back to what you said about the shading. If I was going to shade the union, which parts would I shade? Well, union is everything in A combined with everything in B. So which ones would I put together here? 6, 8, and 2, yeah. Yeah, so if it's A or B, it's asking for which ones are in the union of those two sets. So it'd add the 8, the 6, and the 2. 16. Yeah. All right. Now, I don't think I have any of these, but if it asks, what would the number in A complement or B complement? If I ask that. Well, it's still or, so that's union. All right? Which ones are in the union of A complement and B complement? Well, let's just put the ones in A complement down here. A complement's what's not in A, so that would be 7 and 2. B complement's what's not in B, so B complement, cover up the B, that's 7 and 6, isn't it? So what's the number in A complement or B complement? Well, the 7, I don't include it twice, so it would be, which ones, what would it be? 7, 2, and 6, yeah. Plus. So that is 15. With me there? Is everybody? A complement's the 7 and the 2. The outside and the 2. B complement's the 7 and the 6. Well, and I'm unioning those together, so it's everything in both put together. So I put everything here with everything. Now, I don't include 7 twice. You don't count it twice. So that's why it's just 15. Okay? So or means union, and means intersection. Now one more. And this drives home a point too, because I know a lot of times we try to do something that is not the truth about the universal set. Okay, what would be the number in U?
7.
Yeah, it's more than 7. It's more than 7. The universal set
And everything.
is everything. Right? That's what the universal set is. It's everything. So the set U is everything in the rectangle. It's not just the outside part. Okay? So that's my point here. The universal set is everything. So the number in U would be everything added together. 7, 6, 8, and 2, which is 23. Yeah. So we say, well, that's in U. Well, yeah, everything's in U. It's not just the outside part, okay? It's everything.